Hi Math 2 students. This is lesson 4 in unit 4 and it's a lesson on the graph of the cubic function. So we need to fix something here in our notes. And in this lesson we're going to explore what a cubic function looks like, what its parent graph looks like, and what it looks like when we do transformations of a cubic function. So let's go back and graph the cubic function just like we did in Algebra 1 when we substituted values for x and then got values out for y and plotted those points. Here's what my cubic function looks like in an equation. Y is equal to x to the third. And so if I put in -3 and I cube it, that means to take -3 times -3 times -3. And if you notice, -3 times -3 is +9. And then when I multiply again by -3, I get -27. So my y value when x is -3 is -27. Likewise, if I take -2 and cube it, I get -8. -1 times -1 times -1 is -1. Those we can fill in pretty quickly. 2 cubed is 8, and 3 cubed, 3 times 3 times 3 is 27. So let's graph these points on a coordinate plane and see what the cubic function looks like. We have -3, -27, which you'll notice is way off of our graph, way down here somewhere. -2, -8 would be at this point, -1, -1, 0, 0, 1, 1, and 2, 8. So if I connect these points, the graph of my cubic function looks something like that. The domain for our cubic function is all real numbers. And likewise, the range for our cubic function is all real numbers. And if I haven't shifted my graph, the x and y intercepts are 0, 0. Notice this graph goes right through the origin. So that's the basic cubic function.